viewers, it is Crystal here. I wanted to make another video for you. This video is going to be hypothesis test, like the video that I previously made on hypothesis test. But basically, the video that I previously made on hypothesis test, what we did was we calculated the t-statistic, and the t-statistic is used when you know the mean. In this particular set of hypothesis tests, I'm going to be doing a code review on. You're going to be calculating the population proportion. In order to calculate the population proportion, we're going to be using the z-statistic. So there's a 4-step process to calculate to do a hypothesis test with the z-statistic. And it's one is you formulate your null and your alternate hypothesis. 2, you calculate the z-statistic, which must be used for a proportion. 3, you calculate your cutoff values for your z-statistic, which is going to be z-critical. And then 4, you're going to check whether the z-statistic falls within the rejection region. So I've got 3 examples that I'm going to go over with you to show you the 3 types of hypothesis tests that you can perform for the z-statistic. The first hypothesis test that I'm going to do is going to be a two-tailed proportion test, and where you have 60% of the people prefer tea over coffee, and you conduct a survey of 500 people to show that 280 people prefer tea over coffee. So your null hypothesis is the population equals 60%, and your alternate hypothesis is the population does not equal 60%. So the data that we're going to have is going to be the population is 60%, N is your sample size, and that's 500. Your sample is going to be 280 over 500, or divided by 500, and that's going to be 56%. And then your alpha, or your significance level, is going to be 5%. Okay, so now what we're going to do, the first thing we do is we calculate the standard error. Standard error is the square root of the population times 1 minus population over the sample size. And so your standard error is going to be 0.0219. Then you're going to calculate your z-statistic. Your z-statistic is p sample minus p population divided by standard error. And so your z-statistic is negative 1.83. Now we're going to calculate the z-critical lower and the z-critical upper. So z-critical lower, we're going to use SciPy for that. We're going to import SciPy.stats as stats. So it's going to be SciPy.norm ppf, that's percentage point function over alpha over 2 divided by 2. And then the z-critical upper is stats.norm ppf 1 minus alpha divided by 2. And so your critical level is going to be negative 1.96 and plus 1.96. Now we're going to calculate the p-value. P-value equals p stats.norm.sf. It's going to be abs, that's absolute value, z-statistic times 2. So that's your p-value. And your p-value is your probability. Then you're going to print the results of the sample, the standard error, the z-statistic, the z-critical, lower and upper, and the p-value. And so the only one that I didn't give you was the p-value is 0.0679. So if you were going to be doing the hypothesis test and focusing on just the p-value, then 0.0679, that means that you would accept the null hypothesis because it's higher than 0.05. Now we're going to use the conclusion. If z-statistic is less than z-critical lower, or z-statistic is greater than z-critical upper, then you're going to reject the null hypothesis. The proportion of tea drinkers has changed. Otherwise, you're going to fail to reject the null hypothesis because there is no evidence that the proportion of tea drinkers has changed. And then so what we got is we failed to reject the null hypothesis. There is no evidence that the proportion of tea drinkers has changed. So we failed to reject the null hypothesis. And then this is the diagram that we plotted out the z distribution, which is also a normal distribution, and you found out you've got your z distribution, you've got your z statistic, which is just slightly less than or slightly less than your critical value, and because the z statistic is still within the range, inside the range of the normal value, you can go ahead and accept it. And then you've got the critical value lower and the critical value upper, and the reason why that is because it's a two-tailed test. Now we're going to do another test, which is going to be a one-tailed test on the right. So you have 50% of people wore masks in public. A survey of 600 people shows that 330 people wear masks in public. Use a significance level of, you can see this, my typing is not that great, 5% to see if the proportion of mask wearers has increased. So the null hypothesis is P is less than or equal to 50%, and the alternate hypothesis is P is greater than 50%, and P is your population. So we're going to import the libraries that we're going to need to execute this program, which is NumPy is NP to perform numeric computations, SciPy. From SciPy, we're going to import stats, which is going to perform your scientific computations, and import matplotlib.pyplot as PLT to visualize the data. So we're going to have our data. So your P population is 50%. N is the number of samples, sample size, and that's 600. The sample is 330 divided by 600, and that's going to be 55%. And then your alpha, which is your significance level, is 0.05. Now we're going to calculate our standard error. Standard error equals NP dot square root population times 1 minus population divided by N. And N is your number of samples. So your standard of error is 0.02. And now we're going to calculate your z-statistic. Z-statistic equals P sample minus P population divided by standard error. And so your z-statistic is 2.45. Now we're going to calculate the critical value for a one-tailed right test. Z critical equals stats.norm.ppf. It's going to be 1 minus alpha. So that's going to be 1.64. And now you're going to calculate the p-value. P-value equals stats.norm.sf, and that stands for survival function, z-statistic. So your p-value is 0.0072. So that's less than 0.05. So if you're going to be going with the p-statistic, then you'd have to go with the alternate hypothesis. And the reason why is because it's less than 0.05. And the alternate hypothesis is P is greater than 50%. But what we're going to do is, after we calculated all of the statistics, all of the variables, we're going to print them off. And we already have printed them off, and I've told you what the values are already. And so now what we're going to do is the conclusion. If z-statistic is greater than z-critical, you're going to reject the null hypothesis. The proportion of mass squares has increased. Otherwise, you're going to fail to reject the null hypothesis. There is no evidence that the proportion of mass squares has increased. So I previously said that because of the p-value is 0.05, then you would have to reject the null hypothesis. And so it says in the answer, it says reject the null hypothesis, the proportion of mass squares has increased. And then what we do is we use matplotlib to actually visualize the normal distribution, which is also called a z-distribution. So you can see the normal distribution, you can see the z-statistic is 2.45, and the critical value is 1.64. And since the z-statistic is in the rejection region, then you have to reject the null hypothesis. So the third example we're going to have, it's going to be a one-tailed left test. So let me just say this. Okay, a uni is thinking of having a new lunch facility. If 70% or greater students want the lunch facility, then the uni will adopt the new lunch facility. So your null hypothesis is P is greater than or equal to 70%, and the alternate hypothesis is P is less than 50%. And then you also get another calculation, is NP is greater than 5, and N1 minus P is greater than 5. I'm just going to delete that because hold on a second, I've got to turn the light on. So it's getting dark, so I can't see. I'm just going to delete that. So what we want to do is we want to import the libraries that we're going to need to execute this program. So we're going to import scipy.stats as stats, and that's going to perform your scientific computations. We're going to import numpy as np, that's going to calculate your numeric computations. And we're going to import matplotlib.pyplot as plt, and that's going to visualize your data. So we're going to define our variables. P bar equals 68, and that 0.68, that's your sample proportion. P equals 0.7, which is your population proportion. N equals 750, which is your sample size, and alpha is 0.05, which is your significance level. So we want to calculate the standard error. Standard error equals NP dot square root, and it's going to be P times 1 minus P divided by N. So you can look at your standard error, and your standard error is 0.016. And then we're going to calculate the z-statistic. So your z-statistic equals P bar minus P divided by standard error. And so your z-statistic is neg 1.195. And then we're going to calculate the p-value. That's your proportion. That's your probability. P-value equals stats.norm.sf, and SF stands for survival function. ABS z-statistic. And so your p-value is 0.115. So just looking at the p-value, since the p-value is greater than 0.05, then you would accept the null hypothesis because it's greater than 0.05. So in order to reject the null alpha, p-value greater than alpha, and then so we do reject null alpha is false because the p-value is less than alpha because the p-value is not less than alpha. And now we're going to take the conclusion, but what I'm going to do is I'm going to move the conclusion down here, down to the bottom of printing. Okay. So the reject null alpha is false, so that means you cannot reject the null hypothesis. And because the alpha is greater than the p-value is greater than 0.05. And now we're going to, and we printed off all of the variables, and now we're going to have the conclusion. So the conclusion is, if z-statistic is less than z-critical, reject the null hypothesis, the proportion of mass squares has increased. Else, fail to reject the null hypothesis, there is no evidence that the proportion of mass squares has increased. So our conclusion is, fail to reject the null hypothesis, there is no evidence that the proportion of mass squares has increased. So what we're going to do is, you can see that the z-statistic, neg 1.195, is less than the critical value being neg 1.64, but what we're going to do is we're going to use matplotlib to plot it. So you've got your z distribution, which is a normal distribution, and you've got your z statistic, which is in red, which is 1.20, and then you've got your z critical value, which is neg 1.64, and so you can see that the neg 1.20 is not in the rejection region, and since it's not in the rejection region, you cannot reject the null hypothesis. So that's very interesting, and it shows you, if you plot it on using matplotlib to plot everything, you can visually see it. And so that's it for our 3 examples of hypothesis testing using the proportion. We did a 2-tailed test, which was the first one, and the second one was a 1-tailed test on the right hand side, and then the third one was a 1-tailed test on the left hand side. So you can see the 3 ways that you can perform a hypothesis test. And so that's pretty much concludes this video. I've talked about the hypothesis test for the proportion. In my previous video, I talked about the hypothesis test for the mean. So thank you so much for watching the video. If you like my video, please like and subscribe. And I look forward to making videos of a technical nature for you again in the very near future.